Hello, dear children. Welcome to another class. Today we are going to discuss about extraction of aluminium from its ore bauxite. So let's get started. We all have heard these terms bauxite and alumina, and they are really associated with extraction of aluminium. Let's first have a look on both these terms. What did they talk about? And then we'll continue. So bauxite, yes, what is it? So it is an ore which is rich in aluminium. Do we know what are ores? Ores are the rocks which are rich in metals. Now, bauxite is that ore which is really rich in aluminium, means we can derive out aluminium in a very good amount from it. What is its color? So it is red brown in color and is impure. It is impure. Yes, we are taking it out from the earth crust. So definitely it's going to be impure. And this is how it looks like. So it has some dust impurities like sand impurities, along with some other metal oxides like iron oxide is also as an impurity in this. Let's have a look on the second term, which is alumina. Now, alumina is the purified form of bauxite. The ore bauxite is taken to a bauxite plant where impurities are removed. So basically, we are cleaning that red brown color bauxite, and what we are getting as a result is alumina, which is aluminium oxide. So the chemical formula of alumina is aluminium oxide Al2O3. And how does it look like now? Earlier it was red brown when it was bauxite. Now it looks like white. It's a white powder. So what next? Now we have this alumina, which is away from impurities and impurities. Our aim is to extract aluminium from this Al2O3. So our focus is on alumina now. And now we use electricity to take out aluminium out of the alumina. So electrolysis of alumina is done to obtain aluminium. The alumina is taken to another plant for electrolysis. Yes, we take it to some other plant. Plant means a setup where this electrolysis is done. Or not only this, dear children, actually we can even take aluminium to other cities, other places also where electricity is cheaper, because this process requires a lot amount of electricity. So we search for a cheaper source of electricity. See, this is the setup. Let's have a look on it very closely. So the first thing we should notice is this steel container, the steel cell, which is this. See, we have a big steel case in which the whole process of electrolysis takes place. Then this steel cell is lined with carbon. See, this is the lining of the container and it is done by carbon. We know that carbon is a very good material for electrodes. So we are using it. And see, they have shown negative charge here. It means it is acting as cathode. Absolutely. So this lining is acting as cathode. What next? Let's have a look on the anode. So yes, you saw it right. We have anode hanged like this. So the plus charge here depicts that these are anodes. Okay, what is this? We fill in the ore. What is ore, dear children? Ore is nothing but alumina, Al2O3. That ore is filled in the container. After all, we are doing electrolysis of that Al2O3, right? But it's not just only alumina filled here, but it's also alumina dissolved in molten cryolite. Now, what is this cryolite? This actually forms an important question in exams also. So what is cryolite used for? So cryolite is a compound of aluminium itself, and cryolite is used to, number one, increase electrical conductivity. So it increases the electrical conductivity of this alumina. And secondly, a most important reason is that it reduces the melting point of alumina. The melting point of alumina without cryolite is very high. So it takes a lot of energy to melt it. So in the presence of cryolite, alumina gets easily melted. We are not going to see these bubbles right now. I'll tell about these bubbles later on. But the next thing you should see is that after the electrolysis will be done, we'll get molten aluminium, means the liquid pure aluminium settled here at the bottom, which we can take out with this opening here on the right hand side. So this is how the basic setup works. But not only this, we need to learn about the various reactions happen during electrolysis of alumina. So let's have a look on that. So moving ahead, we have chemical reactions happening. The setup is again in front of us. It's completely the same setup. The number one thing we should focus on here is, I know, dear children, that, electrolysis is all about electrolyte filled, the ions present in the electrolyte, right? If you don't know much about electrolysis and electrolyte, all these things, I'm going to make a separate video on electrolysis. I'll put its link in the description box. You can go and check it there. So ions present in electrolyte are, now dear children, we know that alumina, Al2O3, is majorly present as an electrolyte here. So can you guess what will be the ions present in this electrolytic solution here? Yes, if you said it's Al3 plus and O2 minus, you are absolutely right. Absolutely. Dear children, we should also remember that different reactions happen at anode and cathode. Anode, which is the positively charged electrode, can you guess which of the ions mentioned above? Aluminium ion or oxide ion will get attracted to this positive electrode. Yes, opposite charges attract, and you're right if you said that O2 minus will get attracted to anode. Absolutely right. What happens at cathode? So cathode is the negative electrode. And guess what? Which ion will go to cathode? The positively charged electrode, the positively charged ion, that is Al3 plus ion, because opposite charges attract. Now, there is one more important thing which we should always remember, and that is in electrolysis, oxidation always happens at anode. Oxidation always happens at anode, and reduction always takes place at cathode. You will get all this information about oxidation at anode, reduction at cathode in that video on electrolysis. Go and check that. Now, do we also know that oxidation means loss of electrons? Oxidation is loss of electrons, and reduction is gain of electrons. To remember this, you can also learn the mnemonic oil rig, which states that oxidation is losing and reduction is gaining of electrons. Yes, you heard it right. Now, coming back to this oxide ion present here, what is going to happen? Oxidation, which means losing of electrons. So let's make oxygen lose electrons. When O2 minus loses its 2 electrons, it gets converted to O. But actually oxygen exists as O2. So we'll multiply the whole equation by 2. And here a 4 will come. Yes. Now here Al3 plus, reduction. Reduction is gaining of electrons. Now Al3 plus will gain 3 electrons, and what we'll get is Al. Now we should also add the state symbols. So dear children, always remember that when something is present in ionic form, it's aqueous. Now O2, we all know it's gas. And now you can relate, dear children, that these bubbles are of oxygen gas. Right. So these are one of the products shown here actually. And this oxygen gas is produced close to anode. You can see it. It's around the positive electrode here. Now reaction at cathode. So here Al3 plus is aqueous, it's ionic, and Al is liquid because of the very high temperature inside this setup because of electricity. Aluminium is obtained in molten state, and that's liquid. All right. And now we all know that to write the overall reaction, we need to add the reactions at anode and cathode. So to add these reactions, we should do one thing first, and that is making the number of electrons equal on both the sides. So dear children, what I'll do is I'll multiply this whole equation by 3, and I'll multiply this whole equation by 4, so as to make this number of electrons 12 on both sides. They'll become equal then. So this is 6O2 minus aqueous gives 3O2 gas plus 12 electrons. This is 4Al3 plus 12 electrons, giving 4Al. Yes, absolutely. Now what next? To write the final equation, we are going to add these two equations. So what I'm going to do is I'm going to write these two equations again on the next page, and we'll do it. Yes. So for the overall reaction, let us write the half equations again. So the half equations were 6O2 minus aqueous, giving 3O2 gaseous plus 12 electrons, and Al3 plus aqueous plus 12 electrons, giving 4Al liquid. Yes, now let's add these two equations. While adding these two equations, we should add the left-hand side with left-hand side and the right-hand side with the right-hand side. So the overall reaction is going to be (6O2 minus aqueous plus 4Al3 plus aqueous plus 12 electrons, giving us 3O2 gaseous plus 12 electrons plus 4Al liquid. That's molten, yes. Now the same things on the either side of equation will get cancelled, just like mathematical equations. The other thing to notice is that we can combine this O2 minus and Al3 plus because they have come out from liquid alumina we had, right? So, and you see we had 6 oxide ions and 4 Al ions. So I'm writing a 2 here to make it give 4 aluminium ions and 6 oxide ions. This is going to give us, the products will be as it is, this gaseous plus 4Al liquid. This is how we write the final equation. Yes, this is the overall reaction that takes place in extraction of alumina, extraction of aluminium from alumina. Yes. Now, dear children, we have seen the half reactions happening at anode and cathode, and then we have seen the overall reaction. But there's one more interesting thing which happens in this, and that is we need to remove the anode and replace it again and again. The point is that why does anode needs to be replaced time to time? This is the question which comes in exams also. So do you remember, dear children, what happened at anode was, because of anode being positively charged, the oxide ions get attracted to it and their oxidation happened. So oxide ions lost their electrons and got converted to oxygen gas. Now this oxygen gas, which is produced close to anode being made up of carbon, reacts with this oxygen. And the anode wears off as carbon dioxide gas. And that is why anode becomes thin with time. It reduces in size. And so it needs to be replaced. How will we write this answer in exam is we'll show this reaction, the formation of carbon dioxide, and we'll write that this is anode, this carbon is anode. And we'll say that because carbon goes off as carbon dioxide on reacting with oxygen produced at anode, that is why anode becomes thin with time and we need to replace it. Yes, that is a very important question which comes in exam. Now, because we are done with how aluminium is produced, yes, we know it's produced in liquid form, but we can mold it in different forms and use it. Before going on to the uses, let's have a look on the properties of aluminium. So as we see, aluminium is a bluish silver shiny metal. We know metals are shiny, and aluminium is very important metal, and it's shiny too. It has a low density. Yes, you heard it right. Aluminium has a low density. It is light. Iron is even 3 times heavier than aluminium. You know, because of aluminium being light, it is used in making aircraft bodies and electric cables. It is a good conductor of heat and electricity. Making electric cables out of aluminium is also because of it being a good conductor of electricity. We have aluminium utensils also in our kitchens because they are super good conductors of heat. So they conduct heat well and food gets quickly cooked. It is malleable and ductile. Yes, we know metals are malleable and ductile, and aluminium is one of them, which means that they can be given different shapes, like they can be beaten into sheets and they can be drawn into wires. It resists corrosion. Yeah, this is actually a super interesting point about aluminium, that it is the metal which resists corrosion. Isn't that interesting? Unlike iron, it resists corrosion. And you should also know the reason also, because this question comes in exam. So why this resist corrosion? This is because of a fine coating of aluminium oxide formed on its surface, which acts as a barrier between the metallic surface and the atmosphere. So this is the metallic surface, and surrounding it, we have gases like O2 and 2 water vapor. So we know that corrosion is a result of reaction of metal with water vapors present in atmosphere and oxygen gas. Sorry. So it's because of that. So aluminium oxide is already formed on the surface because of reaction between aluminium and nearby oxygen, which protects the actual aluminium from get corroded. Now it's not very strong. That's true. It's not very strong when pure, like when we derive out liquid alumina from the electrolysis. It's not strong. Even if we mold it in different shapes, it's weak. But it can be made much stronger by mixing it with other metals. And I believe you know that. What are alloys? Alloys are mixtures of different elements together. So to change the properties, we mix aluminium with other metals. It is generally non-toxic. This is true. Aluminium is non-toxic, means it's not harmful to health of living beings, but we need to be cautious. When taken in large quantities, it can harm us. It can harm our brain and bones. Yes, so we should not let a very much intake of aluminium. Now, because we have studied a lot of properties of aluminium, let's have a look on its applications. Where do we use these properties? Here we go. We all have seen aluminum foils being used in our homes as covering the food, right? Now it is because of the malleability of the aluminum that it is used as aluminum foils. The second thing is you see this train, its body is made up of aluminum. Yes, because of its shine and corrosion resistant behavior, it's used to make bodies of trains. Electric cables, as we discussed. There's one thing. Electric cables are made up of aluminum because aluminum is a super good conductor of electricity and it's light also. But we give it a coating of steel core so that it has some strength. Airplane bodies, yes, we make aircraft bodies out of aluminum because it's very light and corrosion resistant too. We all have used these cans, right? So these cans are also made up of aluminum, again, because it's light and it's known corrosion nature. Like it is not going to react with the atmospheric oxygen, water vapor, so it doesn't spoil the food present, the drinks present in it. And with this, we come to the end of extraction of aluminium, its properties and uses. I hope you have learned how to write the chemical equations related to electrolysis of aluminium. Thank you very much for joining me. Take care.